This is the sixth lecture in our unit on algebraic foundations, and we need to introduce the order of operations before we can continue on and do other things. And the order of operations is the procedure when calculating an expression with multiple operations. So we had to sit down and say, well, if there was, I'll put our example up here. If we have this, if we had 6 different people try to do this without a set of rules on which operation to do first, we might have 6 different answers. So we needed a procedure or an outline that says, hey, when you see these, you need to do this first, and then do this, and then do that. And that is the order of operations. And there's a handy acronym for that. Please excuse my dear Aunt Sally. So P is parentheses. So we're going to do whatever inside parentheses first. But parentheses don't just include parentheses. They also include all kinds of grouping symbols like brackets and braces. And you do the innermost first. Innermost first on parentheses. This one doesn't have parentheses, but the next one will have 2 sets of parentheses, and we'll get that in a minute. E is exponents. So we calculate all the exponents from left to right. Okay, this one is the innermost first. From here, exponents, we do all the exponents from left to right. Then multiply or divide from left to right. It doesn't mean do all the multiply first and then do all the divide first. Multiply or divide. And then the last is add and subtract. So using these rules, add or subtract, if I can spell. Add or subtract. So using these rules, we're going to calculate some examples here. This first one here, we're going to start from left to right, and we're going to calculate all the parentheses. We don't have any parentheses, so we're going to go to exponents. And the first exponent is right here. And 4 squared is 16. Notice this negative sign is not in parentheses, so it stays outside. So this is negative 16 plus 24 divided by 3 times 2. So all I calculated was this part here. Now we're going to go, we did the exponents. We're going to go down from left to right and find multiply or divide. So the first one is add, but there's a divide right here. So we're going to do this one next. So we're going to have negative 16 plus 24 divided by 3, which is 8, times 2. And now we do the same thing. We have multiply here. So 8 times 2 is 16. And negative 16 plus 16 is 0. Okay, let's look at another example. We're going to have 4 times 25 minus 5 minus 2 squared. So here we have 2 sets of brackets. Okay, so the first thing we're going to do is the innermost parentheses first, and that's right here. 5 minus 2. So everything else is going to stay the same. And 5 minus 2 is 3. Now inside the parentheses, we're going to do the order of operations. We have a exponent first, so this exponent, 3 squared is 9. So we're going to have 4 times 25 minus 9. And then 25 minus 9 is 16. That's inside the parentheses too. And then 4 times 16 is 64. Sometimes we're asked to evaluate algebraic expressions for given variables using these orders of operation. And I'm going to do this example right here. Actually, I think I have room. We'll do it over here. So we're going to evaluate when x equals 7. And this is 21 minus x plus 2 times 5. Okay. So the first step is to substitute 7 for x. So we're going to have 21 minus 7 plus 2 times 5. Now, we don't have any parentheses and we don't have any exponents, so we go straight to multiply or divide. And from left to right, the first multiply or divide is the last calculation here, 2 times 5, which is 10. So we're going to have 21 minus 7 plus 10. And now I go from left to right. 21 minus 7 is 14, and 14 plus 10 is 24. Okay, let's do the same thing, except we're going to evaluate this one when x is 24. Evaluate when x equals 24, and that's going to be 5 squared times 30 minus x. Okay. So the first step to do is substitute 24 for x. So we're going to have 5 squared times 30 minus 24. Next, we do what's in parentheses. 30 minus 24 is in parentheses. So we're going to have 5 squared times 6. And then we do the exponent. 5 squared is 25 times 6. And 6 quarters is $1.50. So that's how we multiply that out. Okay, sometimes there's a special grouping symbol that comes up in the form of a fraction bar. And it's actually 2 grouping symbols. So if you see something like this, and you have expression divided by expression, we're going to calculate out each expression first, and then the last step would be to divide the two. So here's our example. We're going to do negative 22 minus 2 squared divided by 5 minus 3. Okay. And I have a colleague that used to call this bar over bar. So we're going to simplify the top first. So the first thing we do is the exponent. So we're going to have negative 22 minus 4 over 5 minus 3. We're going to leave the bottom alone, even though we could do 5 minus 3 separately, as long as we do them separately. But sometimes it's better just to leave it alone. Then we'll do the top, negative 22 minus 4. They're both negative, so we're going to add the numbers and get negative 26 divided by 5 minus 3 is 2. And now we have 2 numbers on both of these. 26 divided by 2 is 13. And a negative divided by a positive is a negative. What about absolute value bars? We treat those exactly like parentheses. The only difference is whatever's inside comes out positive. Okay? We discussed absolute value a few lessons ago. Okay, so the first thing we're going to do is what's inside the absolute value bar. That's 10 minus 5 squared, and 5 squared is 25. And then 10 minus 25, that's different signs. So 25 minus 10 is 15. And the bigger sign is negative. So we're going to have the absolute value of negative 15 divided by 5. Now, we find the absolute value here. That's going to be 15 divided by 5. And all that's left is divide. 15 divided by 5 is 3. Okay, we got to do one with the square root. How do we treat square roots? Let's do 5 plus 2 times negative 8 divided by negative 2 cubed minus 3 plus 3 times the square root of 50 minus 1. Okay, so this one looks pretty big. So remember, we're going to do bar over bar. In the top, we're going to have 5 times 2 minus 8. So we do 2 times 8 first. 2 times negative 8, and that's going to be negative 16. And then in the bottom, oh, I'm sorry, I put this 3 on the inside. It should have been on the outside. Negative 2 cubed is negative 8 minus 3. Okay. Oh, and it should have gone over this one here. Negative 8 minus 3. Just butchered this all up, didn't I? Okay. Minus 3 times the square root of 50 minus 1. So this is just going to hang on. We're going to simplify this first, if we can. Okay. 5 minus 16 is a negative 11, divided by negative 8 minus 3, which is negative 11, minus the square root of 50 minus over 1 times 3. 3 times the square root of 50 over 1. Okay. So this now, a negative 11 divided by 11 is 1 minus 3 times the square root of 50 minus 1. Okay, now we're going to do what's under the square root as if it's a parenthesis. Okay, we're not going to take the square root of 50 and the square root of 1. We're going to do with everything that's under the square root. So that's going to be 1 minus 3 times the square root of 49. Now, the square roots are exponents. Square roots are exponents, so we're going to do what's in that exponent. 1 minus 3 times 7. And then 3 times 7 is 21, so we'll have 1 minus 21. And 1 minus 21, they're different signs, so we subtract. And the bigger sign is negative. So negative 20 is the answer. Sometimes, and this goes back to the first lecture all the way back, when we translate words to numerical sentences. And something in parentheses things that are in parentheses that are added are sums. So we would call this the sum of x and y. And things that are in parentheses that are subtracted are differences. So we would say this is the difference of x and y. And we could double that. So this is twice the difference of x and y. Or we could multiply by 1/2, and we could say this is half of the difference of x and y. And we could also say that maybe there's a number in front of a square root. We could say something like that. This would be half of the square root of, well, if you divide two things, you find their quotient. So you would say half of the square root of the quotient of x and y. Or you could say half of the square root of x divided by y. But if you say the quotient, that means if you're taking the square root of the quotient, that ensures that you're taking all of this. Now be careful using that divided by, because you could say half of the square root of x divided by y. That could mean this. So if you use quotient, it ensures it's this. You see the difference there? Okay, so these are just some examples of ways that you could translate things back and forth. The best way to get familiar with this is to find examples and practice. Okay, the next lecture that is coming up will be lecture 7, and it is going to be more simplifying algebraic expressions. I look forward to seeing you then. Until then, happy studies.